Okay, so hello and good day again everybody. Welcome again to Principles of Reinforced Concrete. And in today's video lecture, we would be discussing about the design of singly reinforced beams in reference to NSCP 2015. So once again guys, we would be making use of USD method of designing in this particular video. Okay, so speaking about USD, reiterating the main design philosophy of USD, that the design strength of your member should be greater than the required strength. And thus this equation. So VMN, so this is to be your design strength, and it should be greater than or equal to RMU, and this is to be your required strength. So reiteration guys, that M here stands for moment. So we are actually designing in moment here. But for example that you want to analyze or design in shear, that is to be given by the equation Vn, that should be greater than or equal to VU. But since in this video we would be focusing on the flexural strength and the flexural design of our members, we would be making use of this particular equation. Okay, so in Tagalog guys, dapat mas malakas yung strength ng ating member sa binubuhat niya. So it would be as simple as that. Okay, so for your design strength MU guys, this can be determined using any methods discussed in structural theory subjects such as your moment distribution method, your slope deflection method, or let's say any of the basic formulas discussed in statics of rigid bodies such as your summation forces horizontal, summation forces vertical, and the summation of moments about a certain point, and well, etc. So that is for the value of your MU. Or better yet, you can also use the simplified method as prescribed by NSCP 2015 if it is to be applicable to your system. So once again, that is to be for the value of your MU. And as for our design strength VMN, so for the design strength VMN, this is to be dependent upon these parameters. So it is to be dependent upon the compressive stress of concrete or the compressive strength of concrete, the yield stress of your rebars, let's say the base width of your concrete, so BW, and it is also dependent upon the effective depth, D, and it is also dependent upon the value of your AS, or this is to be the total steel area in the compression side. I mean, on the tension side, I should say. I'm sorry. So it is to be dependent upon these values. So these are to be the values of dependency, but are not limited to. So, okay. So our goal in our designing, since we are to be the structural engineers in this particular member, so our goal once again in our design is for us to come up with the combination of this that will result to a VMN greater than or equal to MU, because this MU is actually given already prior to our designing. So this is to be done in the preliminary designs and in the load analysis part. Okay, so anyway, so these are to be the typical steps. I would just be erasing this. So these are to be the typical steps in our design for our singly reinforced beams. So the first thing that you will be doing is that you will be assuming a trial section. So what that means is that, for example, that this is to be your reinforced concrete beam. So let's say that this is to be your reinforced concrete beam. You will be assuming BW and H. So guys, this is to be H and not D. So D is to be the effective depth. So let's say that this is to be the centroid of your steel rebars. So the value of your D is to be from the topmost flange up until the centroid of your steel. So that is to be your effective D. So, but what you will be assuming here is to be BW and H. And the assumption of the base width and the total height is to be once again dependent upon your rule of thumb and your experience as structural engineer soon. But for example, that you still don't have any experience, just like now. So I am assuming that all of you watching this video are students. So we can base our decisions in assuming these trial sections using this table by NSCP. So these are to be the minimum depth of non-pre-stressed beams, which is to be dependent upon the span length, L. Okay, so for example, that your support condition is to be simply supported. So for example, that this is to be your beam, and you are assuming that this one is a hinge and this one is to be a roller. The minimum depth, So this is to be the total depth. So the minimum depth is to be L over 16. But for example, that your beam is to be a continuous one. So let's say that this is to be your beam. And you have your columns here. And let's say that this is to be continuous throughout. So let's say that this is to be a continuous beam, continuous beam. So let's say that you are designing this particular area right here. The minimum depth of this is to be L over 21. So L over 21. Okay, so let's have an exercise here. So for example, that in this simply supported beam, let's say this is to be 9 meters. So for this particular setup here, so the minimum H requirement is to be L over 16. So let's say H, so minimum H, this should be greater than or equal to. So your H should be greater than or equal to 9 meters. And by the way, guys, 9 meters is also equal to 9,000 mm. So this is to be its conversion, of course. So it should be greater than or equal to 9,000 mm divided by 16 as prescribed here. So looking at the calculator to your left, this is now to be equal to, so 9,000 divided by 16. So it must be greater than or equal to 562.5 mm. And reiteration, guys, that these are only the minimum H. So minimum, if you want to use 600, it is okay. If you want to use 750, then it is once again okay, as long as this is to be the minimum. So it should not be below these values. So yun lang naman yun. But take note, guys, that these factors here, so the factors here are only applicable if your Fy is to be 420 megapascal. So this is to be the yield stress of your steel member. I mean your steel rebars. So what if you would be having another Fy? So for example, your Fy is to be, let's say, 280 megapascal. So wouldn't we be using this once again? So the short answer is, well, yes and no. Because we will be making use of this, but we will be applying another factor, which is to be this. Because according to NSCP 409.3.1.1.1, for Fy other than 420 megapascals, the expression in the table, so this expression here, shall be multiplied by this factor. Okay, so for example, guys, that in this, So for example, guys, that in this one that we have solved, so 9,000 divided by 16. So by the way, I will just be copying this. So for example, that in this particular equation here, and let's say that the Fy that you will be using is to be 280 megapascal, what you will be doing is that you will be multiplying this by, of course, this. So 0.4 plus Fy, and our Fy is to be 280. So 280 megapascals divided by 700. Okay, so that this would give us an answer of, so 9,000 divided by 16 times 0.4 plus 280 divided by 700. 0.4 plus 280 divided by 700. And this is now to be equal to 450. Okay, so as you can see, guys, the minimum H requirement is now to be smaller than that of this. So, ayun lang naman siya, guys. So, okay. So, moving forward, guys, since you already know how to solve for the minimum depth of pre-stressed beams, so let's go to the next step. So, we are already done with step 1, which is to be, well, assume trial section. So, the next thing that you will do is that you will be analyzing the load. So, in your load analysis, you are actually determining the value of your WU, or the ultimate uniformly distributed load. So, if you guys are wondering, isn't it the case that the load analysis should be done before the assumption of trial section? So, hindi ba dapat mauna yung load analysis bago yung assumption of trial section? Short answer, no. Because in your load analysis in your load analysis wherein you would be determining the value of your WU, or the uniformly distributed load, this is to be dependent upon your live load, your dead load, your earthquake load, and whatsoever. Because if you If you can remember your load factors such as your 1.4 dead load, and let's say 1.2 dead load plus 1.6 live load, and etc. So this is to be, of course, your dead load. And your dead load is also dependent upon your trial section. Because for your trial section, for example, that you have assumed a trial section which is very large. So let's say that your BW, let's say, is to be 500. So for example, BW is equal to 500. And let's say your H is to be 900. And you have assumed another one to be BW, this is to be 350. And H to be equal to 650, just for pretend. With this taken into consideration, we can safely assume that this section is way heavier than this section. Thus, if that is to be the case, of course, that is to be the magnitude that you will be inputting in your dead load. So once again, your load analysis is to be dependent, partly dependent upon the trial section that you will analyze. Kasi in Tagalog, pag mas malaking concrete, mas mabigat siya, mas lalaki yung dead load. And if mas maliit yung concrete, mas magaan siya, mas maliit yung live load. So that is why the load analysis would come after the assumption of your trial section and not the other way around. Okay, so for example that we have already determined our W, so that is for our load analysis, we would now be solving for the required strength. And for your required strength, guys, this is to be the value of your MU. So, MU. And your MU here is to be dependent upon your WU. So this WU is to be the magnitude that you will be using in order for you to solve the required strength or the required flexural strength of your member. So once again, you can use moment distribution method, slope deflection method, or the simplified method if it is allowable. Okay, so we have already determined MU, which is to be this particular value here. The next thing that you will be doing is that you will be manually inputting the material properties Fy and F prime C. So these are to be the strength of the members. Of the concrete and the rebars respectively. The rebars and the concrete respectively. So Fy and F prime C. So paano nyo ba malalaman kung anong gagamitin nyo? So for your Fy and F prime C or FC prime, this is to be dependent upon the availability of the product in your locality. So for example, that your hardware is to be selling grade 420 steel, then you will be using Fy to be 420. And for your F prime C, this is to be dependent upon your mix and the size of your aggregates and the type of cement that you will be using. So that is to be discussed in detail in your construction materials testing subject or your CMT. Okay, so once that you have already inputted the values of your Fy and F prime C, the next thing that you will be doing is that you will be determining the required number of rebars. So for example, once again, that this is to be your section. So let's say that is to be our section. You will now determine how much rebar must it have. So for example, it would be having 2 layers, etc. So there. So you will be determining the required number of rebars already. And take note, guys, of these limits. So we have limits. We have the minimum and the maximum. So for your raw minimum, this was already previously discussed. So I will just be moving this here and I will be clearing this para mas malinis tayo. So for a moment. So for your raw minimum, it is to be the greater of this value. So 1.4 divided by Fy and square root of F prime C divided by 4Fy. So if you are confused here, it is said here that this is to be the minimum. But why are we getting the greater value here? So sabi minimum pero bakit yung mas malaki yung pinipili natin? Because basically guys, you must satisfy both of these equations. So this is to be your raw minimum 1 and this is to be your raw minimum 2. And these two raw minimums right here should be satisfied. So dapat masatisfy yung dalawang raw minimum na yan. And for example that in this case guys, so for example that your raw minimum using the first equation, so raw minimum 1 is to be, so let's say for example that our strength of the rebars would be, let's say 420. So 1.4 divided by 420. So this is to be equal to 0.0033. So 0.00333, etc. And for your rho minimum 2, which is to be given by this equation, so that is now to be equal to, so square root of f prime c, so this is to be 20. So let's assume that our f prime c is to be 28 megapascal. So this is just an assumption, guys. So 28 divided by 4 times fy, so 420. So this is now to be equal to 0.00315. So as you can see that this is to be the greater value of the two. So thus, we will be making use of this. So ito yung gagamitin natin. So why is that the case once again? Because let's say that your rho is to be equal to 0.0032 and it is to be greater than this. So this is already satisfied. So check to. However, it is to be less than this. So in that case, guys, we cannot use this steal ratio. And for example, guys, once again, that if your steal ratio is to be 0.0034, so for example, this is to be 4. So with that, guys, it is to be greater than this and this. So check and check. If you would be using the rho minimum, which is to be the larger of the two, which is to be this, if you would be satisfying this, so itong part na to, automatically na nasatisfy siya. So that is why we would be making use of the larger value here. Okay, so moving forward, we also have our NSCP 2015 rho maximum. So if we have a minimum here, we also have a maximum. So according to NSCP 2015, this is to be the rho maximum. So I have already derived this in the previous video lecture because in NSCP 2015, it is said here that the maximum strain, so strain TY, should be greater than or equal to 0.004. And using this value, this equation right here has been derived. Because if you can remember, guys, for your rho max, for your rho is to be equal to 0.85 times f prime c divided by fs times beta 1 times strain u divided by strain u plus strain t. So your strain EU here is to be 0.003 as well as this is to be 0.003. And if you would be substituting 0.004 here, which is to be the allowable by NSCP, you would be arriving at this particular equation. So na-simplify lang siya because this is to be 0.003 divided by 0.003 plus 0.004. That is to be 3/7. So this is just to be the simplified one. So this is to be the limit by NSCP 2015. Okay. And in here, guys, if you want your rho max to be tension controlled, you will be making use of this value. So saan ba nanggaling yan? Because if you can remember this once again, guys, so in this particular what you call this graph for your phi, so this is for your compression controlled region, this is for your transition controlled, and this is for your tension controlled. Though theoretically that this is to be the equation here, so kalimutan nyo na muna yan because there is actually a prescription by NSCP. So according to NSCP, that the strain T, this is to be 0.005. So according to NSCP, once again, that in this particular boundary here, itong 0.005 yung limit natin according to NSCP. So if you would be having a strain of, let's say, 0.0051, so tension controlled na siya. But for example, that you would be having a strain of 0.0045, it is to be at this location already, then it is already transition controlled. So once again, do not forget about this limit prescribed by NSCP, and that is to be 0.005. That is to be, once again, this boundary. So if you want your design to be located here, so ayaw mo ng transition zone kasi pag transition zone, mag-ratio in proportion ka pa. So if you do not want, once again, your section to fall under this region, and you want it to fall on this region so that your phi would automatically be equal to 0.9, in this particular, once again, equation, so rho is equal to 0.85, FC prime divided by Fy times strain U divided by strain U plus strain Ty. I mean, it's strain T. So this is to be 0.003 as well as for this value. And just substitute 0.005 here. So simplifying this fraction would give you an answer of 3 over 8. So once again, this is to be this is to be your rho max if you want your section to be tension controlled. But according to NSCP, it is allowed to go here. So according to NSCP, okay lang na transition zone. So this is to be the limit. So ulitin ko lang guys, in this particular graph, if this is to be 0.005, and according to NSCP, they allow 0.004. So approximately that is to be, let's say here. So 0.004. So let's say that is to be the region. So according to NSCP, once again, you can only design your structure to be in these regions. So wag ka daw pupunta sa region dito. So this is not allowable already according to NSCP. So guys, take into consideration once again guys, your minimum and your maximum. So for your minimum and maximum, for example guys, that let's say for your rho minimum, for your rho, it is to be greater than your rho minimum. And it should be less than your rho maximum. So ito yung limit natin ng rho. But what if that your rho is to be less than your rho minimum? What if this is to be the case? So what you will be doing here is that you will be making use of rho min already. Kasi ito nga yung minimum. So hindi ka pwede bumaba ng rho minimum. So even though that the rho that you have solved is to be below your rho minimum, you will now be using your rho minimum, as you would be having a little bit of a factor of safety already. And if you would be having your rho, let's say greater than your rho max, so anong gagawin mo dito? Would you use rho max? So would you use your rho max? So the short answer is no. If this is to be the case, if your rho is to be greater than your rho max, it is either that you will be adjusting your trial section to a bigger section, or you will be using doubly reinforced concrete already. And that is to be our lesson maybe next week or 2 weeks from now. So I'm not quite sure, but that is to be our lessons to follow. Okay, so once again, you would be comparing your rho with your rho minimum and your rho maximum. But is there a way for you to compute the limits of it without making use of your rho? So the short answer, yes. You can also compare them using the area of the steel already. So once again, your rho is to be equal to the area of the steel divided by the base of the width base times the effective depth. And with that guys, your AS is now to be equal to rho BWD. So for your AS minimum, this is now to be equal to, so I will just be moving this for us to have space. So this is now to be equal to rho minimum times BWD. So that is for AS minimum. And as for our AS maximum, so AS maximum, this is to be equal to your rho max times of course your BWD. So BWD. So etong dalawang to yung limits natin. So these are to be our limits. And once again, if your section is to be below AS minimum, you will be using AS minimum already. But if your AS is to be greater than your AS maximum, you wouldn't be using AS maximum already. Because let's say that this is to be your AS required. So ito yung kailangan natin. And let's say that it is to be greater than your AS max. Then if you would be rounding them down, and in your equation, so once again, phi mn should be greater than or equal to mu. So itong AS required na ito has been solved using phi mn using of course your mu. But if you would be rounding them down, mas bababa ngayon yung phi mn natin. So your phi mn would now decrease, which will result to inadequacy. So hindi na totoo to kasi mas mataas na yung mu kaysa sa phi mn. But if you would be using, let's say, AS min in this case, so for example, that the AS required is to be less than AS minimum. So it is okay that we will be using AS minimum already kasi mag-round up tayo, tataasan natin, and thus we will now be increasing the strength of our section. So we would be having a little bit of factor of safety here. Okay, so that is for the raw minimum and the raw maximum. So we will be having an example later for you to understand it better. But we are not done yet here, guys. So once that you have already determined the required number of rebars and you have satisfied all of these limits, you must also check for the spacing. So ano ba tong spacing na to? So once again, that this is to be your section. So let's say that this is to be your section. And let's say that these are to be your longitudinal bars already. So let's say that these are to be your longitudinal bar 1, let's say 2, 3, and 4. So for example, that you have solved for this. So you must check for the spacing. So by the way, guys, your spacing are to be this spacing. So your clear spacing nila from the corner of the rebar there up to the corner of the rebar here. So this is to be a spacing as well as for this, as well as for this. So that is to be, let's say, your S, or let's say SC. So spacing of the concrete. And it should be greater than 4/3 MSA. So MSA is to be the maximum size of your aggregates. So for example, that in your concrete pouring, you have used 3/4 inch maximum size of the gravel. So for example, yung gravel natin is to be 3/4 inch. So just multiply it by 4/3. So 4/3 times 3/4 inch of your maximum size of aggregates, which is to be your concrete, then this is now to be equal to 1 inch. And if you would be converting this into metric units, this is basically equal to 25.4 mm. So don't forget about this. So this is to be for your MSA requirement. And as for your spacing dB, so the spacing here should be greater than, of course, the diameter of your rebar, and that is to be dB. So for example, that you have used 20 mm. So with that, guys, your spacing should be greater than 20 mm. And as for the last one, so your spacing, this is according to NSCP 2015, guys. So NSCP 2015. So I forgot what section that is. So I think this is to be NSCP. So I would just be writing here if you want to check. So all of these limits are prescribed under NSCP 2015 425.2.1. So check nyo na lang sa NSCP nyo itong mga to. So once again, guys, you will be making use of the largest value here. Or if you do not want to get the largest value, just check them one by one. Pero automatic naman, pag maging adequate na siya sa pinakamalaking value, it would be adequate with the other two already. So just take note of this. And this is to be SC. So what is to be the value for your SC? So paano ba tong SC na to? So I would just be copying this to another slide. So let's say here. So eto. So if you can remember, guys, and if you cannot, dapat maalala nyo that we still have shear reinforcements here. So for example, that this is to be, this is to be your shear reinforcement. So I'm sorry for the inaccuracy of works. So ito, kunwari lang yan, kunwari. So ito yung natin, steel reinforcement natin ng shear. So it would be having a certain diameter. Teka, ang pangit, ulitin natin. So I would be relocating it here para pantay. Ayaw niyang maiurong. Yan. Okay, so this is just for an example, guys. Okay, so let's say that that is to be dV, for example. So this is to be the diameter of your V of your shear reinforcement, and let's say that dB is to be the reinforcement of your longitudinal bar. So red natin para mas So dB. And we still have our concrete cover here. So this is to be our concrete cover. So let's say that is to be CC. So for our spacing SC, so SC is to be equal to, so lilipat natin dito. So SC is to be equal to, so the total base width, so this total here, that is to be BW. So that is to be BW minus, so minusan natin siya ngayon ng dalawang concrete cover. So minus 2cc. So 2cc minus, so this, you have this side of the shear reinforcement here and this side of the shear reinforcement here. So minus 2dv. So black natin para color coding, para hindi kayo mausi. Minus 2dv. And we have 1, 2, 3, 4. So we have 4 bars. So with that, guys, so minus 4db. So that is to be, if you would be having 4 rebars. But for example, you would be having 3 rebars, then that is to be 3 dB. So I think it is better for us to rewrite this in a new letter and let this be letter N. So I'm not quite sure if it is to be visible in the video. So I think it is already visible. So basta may N dyan, guys. So green na nga lang natin para mas makita. So N dB. So the number of bars here. Okay, so we would be dividing this by what? So ang natira dyan is to be the total here. So naibawas na natin yung concrete cover, yung shear reinforcement, and yung longitudinal bars. So in this case, guys, so meron tayo dito, dito, and dito. So yung total yan is to be the total SC, SC plus SC plus SC. And as you can see, we have 3. So basically, this is to be divided by 3 para makuha natin yung SC. And your SC here is to be equal to N minus 1 since we have 4 rebars. So 1, 2, 3, 4. So 4 minus 1, that is to be equal to 3. So it is better if we will be changing this to N minus 1. So N minus 1. So this is to be our equation for our spacing. So it will be dependent upon, of course, the concrete cover, the diameter of the shear reinforcement, and the diameter of course, your rebars. And of course, the number of rebars in one layer. Okay, so that is for the spacing. So okay, so what is to be the next thing that we will be doing? So kailangan naman natin ngayon malaman yung number of rebars. So actually, guys, dapat malaman mo muna yung rebars before doing all of this. So now let's go check in on how we would be determining the required number of rebars. So that is to be using these 3 methods here. So these 3 methods is quite simple, no? So for the first method, we would be solving for the required steel area AS by solving for A and C by summation of forces horizontal. Okay, so in this method right here, guys, this is to be, let's say, the most basic one. No, not most basic one, but this is to be the easiest to remember because basically, guys, you do not need to memorize any equation as long as you know this principle. Basta alam mo tong 0.85 FC prime, AS FY, and well, etc. Okay, so by the way, guys, for your required steel area, so that is to be AS required. For you to determine the number of rebars, so let's say that is to be N RSB, for example, N, that is to be equal to AS required divided by the AS per piece. So for every rebar, so for example, you would be making use of let's say 20 mm rebar, so that is to be pi over 4 times 20 squared. So this is to be for your 20 mm rebar. So for your 16 mm, that is to be pi over 4 times 16 squared, and etc. Basta yun yung gagamitin mo dito. And this is to be in per piece. So this is to be in millimeter squared. This is to be in millimeter squared. Millimeter squared would cancel out. Cancel out pala. So they would cancel out. Then your NRSB is now to be equal to, well, N pieces. Kasi piece na lang yung natira dyan. So that is for your number of rebars. Okay, so anyway, so for the first method of determining the required steel, so ang sabi dito, solve for A and C by summation. Teka, so we have an error here. So This is quite misleading. So, yan na lang isipin nyo. So, you would be solving for A and C by any means possible. So, it is not necessarily that you will be using the summation as long as you will be solving for A and C. Then, once that you have solved for A and C already, you will now be solving for AS. So, paano ba yan? So, in this case, guys, I mean, in this method, once again, you do not need to memorize any formula as long as you know this principle. So, paano ba natin ma-solve yung A? So, ang given sa atin is MU. So, we already have our MU, we already have our BW, and we already have our D. Of course, as well as for FC prime and FY. So, by solving for A and C, so as you can remember guys, that phi MN is to be greater than or equal to MU. And in this case guys, we will be equating them para alam natin kung ano yung minimum. So, with that guys, this is now to be an equal sign. So with that guys, so MU, so by the way guys, this is VMN I should say. So VMN is to be equal to MU. So baliktarin ko lang, this to be MU and this is now to be equal to phi MN. So ano ba ang MN natin? So we can either use AS FY times D minus A over 2 or let's say 0.85 FC prime times AB times the lever arm of D minus A over 2. Okay, so with that guys, we would be making use of the compression by concrete yung moment natin. You should already be familiar with this guys. So, ayun. So, 0.85 times FC prime times AB. So, this is to be the total compression force here. So, yan. Times the lever arm. So, the lever arm here is D minus A over 2. So, times D minus A over 2. So, as you can see, guys, we already have the value of FC prime, A, B, D, and, of course, MU. And as for our value for phi, we will be assuming that it is 0.9. So, assumption muna. So, we will be assuming that phi is to be equal to 0.9. And with such, since A is the one being unknown, then, of course, solve for A. So, once that you will be solving for A, and disclaimer guys, you would be using quadratic equation here, or you can use shift solve or mode 3 in your calculator if your calculators have such features. So yun, solve mo yung A nyo. Then, once that you have solved for the value of A using this equation, so yun, meron na tayong A, you can now solve for AS. So if you can remember guys that MU is once again to be equal to VMN and VMN, so that is to be phi, and MN can also be written as AS FY times D minus A over 2. So we already have our A, we already have our A, D, FY, and MU. So the only one unknown here is to be AS. So AS naman talaga yung nahanap natin. So we can already solve for AS. But we have a catch here. So, a while ago, we have assumed here that the value for phi is to be equal to 0.9. And ulitin ko lang, this is just to be an assumption. So, we can make sure by solving for C. So, guys, if we already have our value for A, we can solve for C. Solve for C dito. So, we can solve for C because C is to be equal to A over betas of 1. Because if you can remember, A is equal to betas of 1C. So, cross-multiplying, magiging ganito yung equation natin. And once that you already have the value for C, so you can solve for Fs already. So, Fs, so I'm sorry for the disorganized solution, pero ito nang tignan nyo na sinusulat ko. So, Fs is to be equal to 600 times D minus C over C. So, if you can remember that. So, yan yung equation natin for Fs. And once that you have solved for Fs already, you can now check using this particular area here. So, pwede nyong i-check ngayon using this. So, if your Fs is to be equal to Fy, it means that this is to be its limit. And if your Fs is to be equal to 1,000, by the way guys, itong part na to, this is already 1,000. No? So, this is already 1,000 megapascal. So why is it the case that this is to be 1,000 megapascal? because the strain here, according to NSCP, is to be 0.005. So strain T is equal to 0.005. And as you can remember, strain is equal to, so Fs divided by 200,000. And your strain T is now to be equal to 0.005. So 0.005. So cross multiplying, so Fs is now to be equal to 1,000. So confirm natin. So 0.005 times 200,000. So 1,000. So if you already have solved for your Fs, so check nyo siya kung if it is greater than 1,000 megapascal, it means that your phi is to be equal to 0.9. And if it is less than 1,000 megapascal but it is still greater than Fy, then it is already transition controlled. And with that said, guys, you will now be adjusting your value for your phi accordingly. But for example, that once again your Fs is to be greater than 1,000, it means that your assumption is correct. So tama yung assumption natin na 0.9. Okay, so that is just to be it, no? So once that you will be solving for your AS already, then substitute them. Then ayun na, yung itong AS na to ngayon, so the value for your AS that you have solved here must be compared with the AS minimum and AS maximum. And it must be, so your AS required must be greater than your minimum AS, say AS min, and it absolutely must be less than AS maximum. So if it is greater than, if it is less than area minimum, so okay lang yon, i-adjust mo na lang pataas yung yung area mo. And if it is already let's say if it is greater than your AS maximum, so hindi na pwede yon, it is either that you will be changing your section, so lakihan mo yung section mo, or you can also use double reinforcement or doubly reinforced concrete. So hindi na siya SRB, DRB na siya. So that will be discussed in the videos to follow. So anyway, yun lang naman yung idea natin for this. So for number 1. So as you can see, there are no equations new. So there are no new equations. Parehas pa rin sa ginagamit natin sa analysis. It's just that bali-baliktad yung given. So that is for method number 1. So in this, guys, wala kayong kailangang i-memorize as long as you understand the principle here. So quite honestly, I myself, ito lang yung talagang ginagawa ko kasi wala kang kailangang i-memorize. Okay, so for the second method, guys, this is to be, let's say, the fastest approach for you to solve for the required steel area. And you will just be using these two equations here. Though it is long, and honestly, in my board exams, I have used these methods. Kasi dito sa number 1 and number 3, magka-quadratic equation ka, which I will show you later. Basta magka-quadratic equation kasi dyan. Ayun, dito kasi sa sa resisting moment, direkta, ibibigay niya na kung ano yung required steel area and required steel ratio. Okay, so what you will be doing here is that, of course, you will be making use of this equation. So you already have the value of your MU and you will be assuming the value for your phi. So assume lang. And after determining the value of your Rn, so just substitute them here. So 2Rn, then this is to be Fs, but you are assuming that it is to be a, let's say, a transition or compression control. So meaning that this should be Fy already. So Fy. Then ayun, substitute all values, then you will be arriving at an answer of ρ. Then for you to determine the AS required, so by the way, this ρ here is to be your ρ required. So ρ required times BWD. So this would give you an answer of AS required. So ayun, itong number 2 yung pinakamadali actually. And for the third method, you can solve for ρ via this equation. So this is actually the shortcut that I taught you last video lecture. So ito na-derive to with the help of Sir Segundo. So ayun, so MU is to be equal to phi rho, ba't ko pa rin nire-write, nakasulat naman na dyan. So MU is to be equal to phi rho BD squared Fy times 1 minus 0.59 rho Fy F prime C. So rho is to be unknown. So solve nyo yan using quadratic equation or shift solve if your calculators have shift solve features, then ayun, raw required. Then from your raw required, you can now solve for the AS required. Then with your AS required, guys, so divide nyo ngayon to ng area ng pieces, I mean area AS per piece, then you will be arriving at an answer of number of rebars. Then after that, check nyo ngayon dito. So after getting the value for your AS, check nyo ngayon ulit itong mga ito. So check for the raw minimum, raw maximum, and the spacing limits. So that is pretty much it for the introduction of our design for singly reinforced concrete beams. And as for your betas of 1, so ito kasi masyadong na-overlook, especially in your exams, that guys, your betas of 1 is to be equal to 0.85 if it is in the range of 17F prime C up until 28. So, pag nasa 17 to 28 siya, it is automatically 0.85. But if it is to be at this range, you would still be using this equation. So, minus. So, you do not actually need to memorize this as you know the, let's say, this idea. So, 0.85. So, for your betas of 1. For your betas of 1 in the range of 28 up until 55. So, in your 0.85, you would now be subtracting. So, subtract kayo ng 0.05 for every 1 megapascal that is to be the difference from 28. So, for example, 29. So, 29. Lagi ko na lang muna itong equation para mas maintindihan nyo. So, once again, guys, mas maganda na lang ata ang ganito. Dito na lang yung point divided by 7. Okay, so anyway, so there. So, you would be subtracting 0.05 divided by 7 for every 1 megapascal that is to be increasing from, of course, 28. So, 28 nga yung limit natin. Ngayon, pag mas mataas siya ng isa, then, ito yung maibabawa, 0.05 divided by 7. So, let's have that for an example. So, for example, that, once again, your F prime C is to be 29. So, 0.85 minus 0.05 divided by 7 times 29 minus 28. So, that is to be equal to, of course, 0.08428 something. And kapag lumagpas na naman to, so this is to be, let's say, 30. So, let's say that this is to be 30. Then, substitute nyo lang ulit dito na 30. Instead of 29, use 30. So, our U betas of 1 is now to be equal to 0.8357. So, once again, you do not need to memorize this equation as long as you know the principle that for every 1 megapascal that you will be increasing from 28, so for every 1 megapascal, magbabawas ka ng 0.05 divided by 7. Up until, of course, yung 55 natin. Kasi yung 55 natin yun yung limit. If it is to be, let's say, 60 megapascals already, that is to be stuck at 0.65. So, try nga natin sa 55. Check lang. Hindi ko pa na-check to eh. So, if 55, so 0.65 yung part dito. So, ayun lang naman. Anyway, so, though 0.657 nakalagay dito, you would be using, of course, 0.65. Basta yun lang yung sa betas of 1. Kung ayaw nyo i-memorize to, edi ganito na lang gawin nyo. Kung di nyo naintindihan to, then it is better if you would be memorizing this. Just take note that the equation in NSCP is erroneous. Kasi dito, parang minumultiply mo siya, which is wrong. You should be subtracting this. So the correct equation here is to be 0.85 minus 0.05 times F prime C minus 28 divided by 7. So this is to be the correct equation. So once again, do not multiply them, but subtract them. Okay, so in the next video, we would be discussing about this sample problem right here, in which we have solved for its required strength in the previous video lecture that we had. Okay, so stay tuned for the next video.